So anhydrides are another functional group that really only see use synthetically. As with acid chlorides, generally too reactive to find in nature. Because of that, they're typically also a functional group that we need to synthesize, when we want to use or need them. Now, there are two primary ways to make anhydrides. One is that you can, in certain cases, take a carboxylic acid and dimerize it. And that can be helpful. The biggest problem here is that this is only useful if you want an anhydride where your two R groups are the same. So for the purposes of this video, we're going to talk about the other primary method for making anhydrides, which is the reaction of a carboxylic acid with an acid chloride. Because if you do it in this way, you don't need to have the same R group on each side. And you can make, at least in theory, any anhydride you want with two different R groups. So how does this reaction work? We're not going to go over the synthesis of the acid chloride here. You can find that in the acid chloride video. But just to review briefly, making an acid chloride means that you take a carboxylic acid, treat it with thionyl chloride, and your OH group gets replaced by a chlorine. Once you have the acid chloride that you need, you just mix it with the corresponding carboxylic acid for the anhydride you're trying to synthesize, and they do a basic acyl substitution reaction to get you your product. So for our example here, we'll use acetic acid with benzoyl chloride. The hydroxyl group on the carboxylic acid will function as our nucleophile, attacking the acid chloride. That forms our tetrahedral intermediate. Tetrahedral intermediate breaks down by loss of the leaving group and reformation of the carbonyl. And then we just need to lose this proton. Anything that can function as a base will pretty easily remove that proton. And we're left with our anhydride as the product.